In this video, we are going to solve a problem based on conservation of momentum. Here we have got a ball with a mass of 50 gram which is moving at 10 meter per second. So let's just draw that. 50 gram we have to convert into kgs, so we'll divide by 1000 to get 0.05 kg. It collides with a second ball with a mass of 30 gram moving at 3 meter per second in the same direction. That's important, in the same direction. So first ball we made it move to the right, so the second ball should also move to the right. So again 30 gram we have to convert to kg, so divide by 1000, 0.03 kg. Then let's draw it, and the speed is 3 meter per second. So that's before collision. After collision, the 50 gram ball moves at 8 meter per second. So it was moving at 10, now it has become 8. So we will change the velocity as or speed as 8 meter per second, but it's still moving to the right. And for 30 gram mass, we don't know what's the speed, so we write it as x meter per second. That's what they are asking in the first part. So I've just redrawn it under part A. Now we'll write total momentum before equal total momentum after, which is the principle of conservation of momentum. Then we apply the formula P equal mv. So we'll put 0.05 times 10, that's for the first object, plus 0.03 times 3, that's for the second ball, equal after. So look at the picture which is after. So 0.05 times 8, that's the momentum of the first object after collision, plus 0.03 times x. So for 30 gram after collision, we don't know what's the speed, so we write it as x. Now we use calculator to solve. We'll move 0.4 to the other side, and then we subtract it and divide by 0.03 to get the value for x as 6.3 meter per second. Then it's asking what is the change in momentum experienced by the 30 gram ball. That is the second object, 30 gram ball. It's asking for change in momentum. So we'll write mvf minus mvi. So 0.03, that is 30 gram ball converted to kgs. Vf is 6.3 meter per second. That's the value for x which we got. That is after collision, which is the final velocity. So we write that minus 0.03 times 3 meter per second. If you look at the diagram, before collision the 30 gram ball was moving at 3 meter per second, so that's its initial velocity. Then we calculate it, get the number, and put the unit, which is kg meter per second. Let's do one more type of problem on conservation of momentum. Here we have got a homemade cannon ball which is constructed to deliver an impulse to a tennis ball and accelerate it forward. If the mass of the cannon is 10 kg and it fires the tennis ball of 0.2 kg with a velocity of 8 meter per second, calculate the recoil speed of the cannon. So the cannon and the ball, they were both together at rest before explosion. And after explosion, the ball will be released in the right direction, that means towards the right, and the cannon will move backwards, that is recoil, to the left. So mass of the cannon is 10 kg, mass of the ball is 0.2 kg as given in the problem. The ball moves at 8 meter per second and the cannon will recoil, that means it will move backwards to the left, and we don't know what's the speed with which it is moving backwards. When the tennis ball moves forward, the cannon will move backwards. Now we'll apply total momentum before equal total momentum after. Before everything was at rest, so 0 equal cannon is 10 kg mass times its velocity, we don't know, so x, plus the ball is 0.2 kg times its velocity is 8. So we write 0 equal 10x plus 1.6. Take 1.6 on the other side, it becomes negative 1.6. Divide by 10 on both the sides, and we get the answer as negative 0.16 meter per second. Negative means the cannon is moving to the left, which is the case because tennis ball is moving to the right, so the cannon will recoil and move to the left. So 0.16 meter per second to the left.